All right, let's talk about something that's happening inside your computer literally millions of times a day. We're going to follow the dramatic life, the death, and even the strange afterlife of something called a process. Let's get right into it.
You know the drill, right? You double-click an icon or you type a command and boom, something just happens. But what is that something? What's the secret story that unfolds in that split second between your click and the program actually popping up on your screen? That's the journey we're about to take.
So every story has a beginning, and for a process, that beginning is birth. This is the exact moment when a simple, lifeless file on your hard drive suddenly gets the spark of life and becomes something real, something dynamic.
Think about it like this. A program is just a recipe sitting in a cookbook. It's just a set of instructions, right? Static. But a process, well, that's the chef in the kitchen actually cooking. It's using the ingredients, it's taking up counter space, it's making the kitchen hot. It's the program in action.
So how does this transformation from recipe to chef actually happen? Well, the operating system uses a special command called a system call. And in this case, the call has this perfect name, fork. Seriously, just think of it as the clone button for processes.
And it's actually kind of straightforward. An existing process, which we'll call the parent, decides it needs some help. It calls fork, and poof. Just like that, the operating system creates an exact, identical copy of it. We call that copy the child. It's an instantaneous clone.
So for just a split second, you have these two perfect clones. They have the same memory, the same code, everything's the same. But, and this is the most important part, there's one critical difference that tells them apart. The new child gets its own, totally unique Process ID or PID for short.
Yeah, this PID is the operating system's way of keeping tabs on everything. The best way to think of it is like a unique social security number for every single process running. No two active processes can ever have the same one. It's their identity from birth until death.
Okay, so our process is born, but its life isn't just one constant sprint to the finish line. Nope, it's actually this dynamic journey through a bunch of different phases, or what we call states.
You know, just because you have a program open doesn't mean it's actually using the CPU. In fact, most of the time it's not. It's probably just waiting for its turn, or maybe it's waiting for you to click something. And the master conductor waving the baton here is the operating system's scheduler.
And these are the key states in its life. A process can be ready, which just means it's standing in line, waiting for its shot at the CPU. Then it can be running. This is its moment in the spotlight, actively doing work. It could be waiting or sleeping, maybe paused because it needs to get something from your hard drive. And finally, terminated. The job is done.
All right, so how does a process actually bounce between all these different states? Well, it's not random at all. Specific events are what trigger these big changes.
Let's walk through it. Say a process is happily running, but it suddenly needs to read a file. Boom, it gets moved to waiting. As soon as that file is available, it doesn't go back to running. It moves to ready. It's back in line. Then, when the scheduler points at it and says, "You're up," it goes back to running. And to keep things fair, if it uses up its tiny little time slice of CPU time, it gets yanked and sent right back to the ready queue to wait its turn again.
And that is the whole game for the scheduler. It's like this microscopic traffic cop, just flawlessly conducting a symphony of thousands of processes at once. It gives each one a tiny slice of time, which is what makes your computer feel like it's doing a million things at the same time. But, you know, every life has an end. And this brings us to the final and I think maybe the most fascinating part of our story, the death of a process, and the weird family drama that can happen next.
Hey, remember that whole parent-child relationship from the fork call? Well, that wasn't just a one-time thing. It actually creates this massive hierarchy, a whole family tree of processes that goes all the way back to the very moment you turned your computer on.
And at the very top of this family tree sits the big boss, PID1. You might see it called Init or systemd. This is the great-great-great-grandparent of every other process on your system. It's the first one born when the OS boots up and the very last one to die. Some people call it the God process, and it has a very, very special job. And this is where things get a little weird, maybe even a little spooky. What happens when a parent dies before its child? Or what if a child dies but its parent just doesn't notice? So first up, we have the orphan. Picture this. A process is running along just fine, but then its parent process unexpectedly dies. So it doesn't just wander around aimlessly, the system has a safety net. The God process, our old friend PID1, officially adopts it. It becomes the new parent, making sure that orphan is taken care of and cleaned up properly when its job is finally done. And now for the one with the really cool name, the zombie. Okay, so a zombie process is already dead. It's done. It has finished all its work. The problem is, its parent, which is still alive and kicking, just hasn't gotten around to acknowledging that it died.
Now, let's be super clear here. A zombie isn't using any memory or any CPU time. It really is just a ghost in the machine. It's just a single entry that's stuck in the system's main process list. And it's just sitting there, waiting for its parent to finally come along and collect its death certificate, which basically just says whether it finished its job successfully or not.
So let's break it down one more time, nice and simple. An orphan is alive, but its parent is dead, so it gets adopted. A zombie is dead, but its parent is alive, and it's just waiting for that parent to do the final cleanup. Two very, very different situations.
And look, this whole parent-child cleanup dance, it's not just some weird, dramatic quirk of the system. It is absolutely essential for keeping your operating system healthy, efficient, and making sure old dead processes don't clutter up the works. So let's just quickly recap that incredible life we just followed. It all starts with a fork, creating a child from a parent. Then it lives this crazy life, constantly hopping between states, all managed by the scheduler. And in the end, that bond with its parent decides if its death is a clean one or if it leaves behind an orphan or a zombie.
Which kind of leaves us with a fun thought, doesn't it? Having a few zombies on your system is totally normal, but if you see a whole horde of them, it can be a sign that a program is buggy and isn't cleaning up after itself. So the next time your computer feels a little bit off, you can ask yourself, is it just a bug? Or could it be haunted by ghosts in the machine? Thanks for tuning in.